Welcome. FIFA, upward motion. Welcome again. Now, problem number 2. If a body is thrown up with a velocity of 15 meters per second, find the maximum height attained by the body. Take J equal 10 meters per s square. Now, let's solve this problem. My object here is thrown with a velocity which is equal to 15 meters per second. Let's solve this problem to find the maximum height. Reached by the body. Now, in solving this problem, which data do we have? We have data. We have J 10 meters per s square. We have initial velocity 15 meters, and from this information let's use this formula. We know that at the maximum height V equals 0. See here, at this maximum height, V equals 0. Using this fact, find now this formula get 0 u square minus 2j h. Now we are asked to find the h. Solving for h, gh equal u. Now solving for h, find u square over 2j. Now pressing 15 square over 2 times 10, we get 225 over 20 equal to 11.25 meter. This is our required h. Now problem number 2. Now problem number 3. 2 is already done. Now 3. If a ball is thrown vertically upwards with speed u, find the distance covered during the last 10 seconds of its ascent. Now I try to draw. Now look at this. Now This is unknown h. Last second, let's call this my displacement, my space, the distance covered during last 10 seconds. Now from here up to, we have the time of ascent equal time of ascent u over g. Now taking this time of ascent u over g, negative last seconds. Yes, good. This is my unknown height. Unknown height. This one. With this information, you find that the time of flight, negative last t here already. With this information, we can find, let me show you, find the distance covered. Yes, find the distance covered during the last second of its ascent. We have to find the distance covered. My h, these are known here. These are known. This h here, this distance here. Have to find this h. Yes. Velocity, let me show you. Velocity in last second. Velocity in last second equal v equal u negative j2. This formula is this one, the first one. Use this first one. Now v equal u negative t, using this time, this one, u over g minus t, we get u negative j u g plus gt, get u negative u plus gt, because here I cancelled this. I get v equal, see here, 0 plus gt. Now v equal gt. My velocity, instantaneous velocity. Now, having v, use V equal U square over GT. At the maximum height, remember, this equals 0. Now using this fact we have at the maximum height you have V equals 0. Now 0 equal G T square negative 2JH, negative 2JH. Let's solve. I find 2JH equal JT square. Now you find that H equal J square T square over J, having this and this cancel. I have here, remember these two also. I have 1 over 2 J T square. This is my height covered during this last test second. This is the height used during this last test second. At this point, V equals 0. But before reaching this point, I still have this initial velocity. It's why I used this JT. This was my view. Now our problem is solved. It was problem number 3. Find the maximum distance covered during the last second. We find is H equal 1 over 2 JT square. Now